Welcome at the Hydrogen Fuel Cells Europe here at the Hannovermesse 2022. We are here at the public forum. My name is Muriel Bouakas and I will be hosting the next 20 minutes for the upcoming interview. If you're not already seated, please join us, have a seat, sit down, get some refreshments, relax and listen to the upcoming interview. We will talk about how to find your way through the jungle of leak testing requirements. And please welcome on stage for this from Pfeiffer Vacuum, the leak detection expert, Dr. Rudi Konwitschny. Great to have you here.
Thank you for the invitation.
Let's start with an easy question for you. Tell us a bit about Pfeiffer Vacuum. What are you doing exactly?
Yeah, Pfeiffer Vacuum, as the name says, is a vacuum technology company. So we are the world's biggest manufacturer of high vacuum pumps, of turbomolecular pumps. We complement the portfolio with primary pumps, which are compressing against atmospheric pressure, process pumps for the semiconductor industry, wafer contamination measurements for the semiconductor industry, and last but not least, leak detection devices. Yeah, because many of the detectors are working in vacuum, so the expertise about leak detection devices often is related to vacuum companies.
Vacuum, okay. And since how long is the company active in the fuel cell market?
Well, there have already been attempts to establish a market, let's say 17 years ago. I remember well, for example, the Mercedes A-Class. There was a demo fleet of several hundred cars equipped with fuel cell technology. I remember the BMW 7 Series with a combustion engine. I remember Linde building a hydrogen fuel station in the gas works in Unterschleißheim near Munich. So I was already involved at that time.
Okay, so before we go into the topic of leak testing requirements, maybe you can talk quickly about yourself. What is your role at Pfeiffer Vacuum? But also, what is it? You have also different roles. So maybe tell us a bit about this.
Yeah, first of all, my role is I'm a leak detection application specialist. So I'm advising to our customers how to select the leak detection method, what is the best device, what is the best method, what is the best test recipe, and so on. I'm also teaching quite a lot in leak detection. And I'm also a member of the technical committee on leak detection of the German Society for Non-Destructive Testing, a committee that I have the pleasure to head since 4.5 years.
The absolute expert we have here on stage when it comes to leak testing requirements. So, but when we want to talk about leak testing, we also have to talk about tightness.
Yeah. Mm-hmm.
Can you start with this?
Well, first of all, tightness is nothing absolute. Tightness is something we can measure. There is no such thing as absolute tightness, 100% tightness, perfect tightness. This does not exist. Yeah? So we can measure tightness. So if you buy a bag of potatoes, for example, this is fit for function. You won't lose the potatoes on your way back home from the supermarket. Then, for example, if you think about a fisherman's net, the small fish are supposed to escape in order to grow. So this is also functional tightness for a certain type of fish. Yeah? And every industry, every application has its own demands for tightness. And this is something where we need still to find common ground, what we are applying in the hydrogen community.
Okay, so now when we talk about leak testing requirements, what are typical applications we're looking at?
There are numerous applications. So, for example, if you think about a classical combustion engine car, there are more than 200, 300 parts which are leak tested. So this ranges from the water reservoir for your wiper. This goes to demanding applications like environmentally driven testing of refrigeration and air conditioning components inside the car, safety components like airbag igniters, airbag gas generators, and transferred to the hydrogen world, there are also numerous components. You can start with the membranes. You can measure the gas throughput through the membrane. You can measure individual bipolar plates. You can measure stacks. You can measure balance of plants components, like, for example, an anode recirculation blower. And also in hydrogen combustion engines, you can measure components, many of them, for example, injectors. So there are very, very many parts who need to be leak checked.
And Pfeiffer Vacuum is checking them all, like the whole value chain in the hydrogen market or in the fuel cell market? You are able to do the leak testings?
We are able to supply the instruments with which the devices are tested. We are no integrators. We do not build full systems. We can support, let's say, builders of construction lines in order to integrate the leak detection station, yes. But we are not a full system supplier. We're doing the instruments.
Okay. So let's say I realize that I have to do some leak testing. How can I approach the leak testing requirements to choose the right methods for whatever I have to do?
Well, we are in Germany, so every German needs solid ground under his feet on a regulation. Yeah? So if I'm looking for relevant regulations in the leak testing environment, I can find one which is 25 years old, EN 1779. And what I like about this regulation is a very, very clear structure on how to select a leak detection method. The approach is from the part that you need to test. So first of all, you have to think about the gradient, the pressure gradient that you apply. So do I have an outside-in test, for example, for a vacuum chamber, or do I have an inside-out test for a compressed tank, for example? The next question is, do I have to apply a method which is testing a section of the unit that I want to test, or do I want to have an integral test? And the third criterion is, do I need to locate the leak, or do I need to measure the leak? For example, in order to have an integral method and to define a pass-fail criterion which defines good or bad, send to the market or scrap or rework.
So what are the standards at the moment in the market? You said there are requirements for everything, but how is it going? Are there standards, or is it still
yes,
like
there are
blurry?
standards. There are standards which have reached a high level of maturity in the leak testing world. The standards which are specific for the hydrogen world still have some room for improvement, I would say. So there is a lot existing, for example, for tanks. So this is existing since quite a long time ago. And there are also standards which are quite young, less than 5 years old. For example, for electrolyzers, for fuel cell stacks and so on. And they're giving some indication about a proper way of leak testing. Yeah?
You said they have room for improvement. Can you give an example, or why do you say room for improvement?
I have mentioned this old regulation before with the defined selection criteria. So if I'm going this tree, this decision tree, to the end, which leads me to a quantitative integral measuring inside-out method, then I'm having selection of 8 methods. For example, an existing standard, a safety-related standard for fuel cell stacks mentions only 2 of these methods. So I don't see any reason why we should limit ourselves, restrict our toolbox, and not be able to apply the full range of potential methods.
Is this a problem of lack of knowledge, or why is the hydrogen world limiting themselves to 2 methods if they could have 8?
I have entered discussions with the German godfather of this regulation. So he was very open, interested in the constructive improvement for this regulation. And he has provided some material from the person who has done some technical work prior to writing the regulation. So this person obviously was a proven expert in leak testing with air. And in this regulation, there are mentioned, for example, leak testing with air by flow measurement and by pressure decay measurement. So 2 very well implemented methods. And in this regulation, you are allowed to use air as a gas, and you're allowed to use helium as a gas. But the regulation does not explicitly mention detectors which are selectively for helium. So, for example, you can do helium testing in an unrivaled way when it comes to sensitivity, when it comes to selectivity, when it comes to decoupling of environmental parameters, like, for example, compression heat. So this has a massive influence on leak testing with air. But more important, the bigger the sample, the higher the pressure in the sample. There may be some volume changes in an elastic sample. And the tracer gas methods using air or even forming gas, hydrogen, they're insensitive to these environmental influences. So that's why I am daring to criticize a regulation. Yeah.
Yeah, definitely. I mean, I make an assumption. You can challenge it, please. It's a young industry, and somehow there's always a challenge between moving forward and moving fast, and then regulations, having regulations usually takes a long time to get them in place and standardize. So it's maybe because of the speed of the changes that the regulations are not yet as elaborate as they could or should be.
This is one side of the story, yes. And the question is, how do we get fast? So yes, we can work with the regulation committees, what I'm trying to do personally, but we can also write official technical documents, let's say, which are helping, which are giving us a guideline. It can be a white paper. And for example, this technical committee on leak detection is also issuing directives for fields of applications which are not yet covered by regulations. So this may be a way to get something faster to the market and aiding the community in order to select the right method and the right test recipe, the right test parameters, and so on. So this is also a way of communicating.
You mentioned the timing. You are the expert. How long does it usually take for a new standard or requirement to be in place?
Several years normally, yeah.
Maybe I open up to the audience. Are there any questions from the audience so far? And I continue. Why is it important to have standards? A very basic question.
Yeah, we need to have common ground. So we need to avoid growing into any possible direction. So we have to standardize something, and this basically exists. It just needs to be converted and adapted to the special needs of the hydrogen community.
And maybe based on this, what are the challenges that you see when it comes to leak testing requirements, or in general when we talk about requirements and standards to be established?
Many of the standards which are existing are driven by safety concerns. So, for example, in a standard covering safety of fuel cell stacks, there is written you need to measure, you need to document your measurements, you need to correct this in a given way, so apply a safety factor, and then you have to publish this data. You have to give this data to the people who are designing the ventilation. Yeah, so the motivation clearly is to avoid the low explosion limit of hydrogen in air, and the method which is proposed is pressure decay over a duration of 120 seconds and with zero pressure decay. So there are other regulations from the leak detection world which are saying specification of a leak rate zero is not allowed because there is always something that you can measure. So you need to take assumptions, but the leak rate, if you measure it this way, is depending on the volume. Yeah? So the bigger the volume, the higher the pressure, the worse is the result that you're going to get. For example, if you have a small stack with less than 1 liter per second, less than 1 liter volume, then you can achieve leak rates. If you can convert it to bubbles, let's say you immerse a bicycle tire into a tub, into a water bath, then you have escape of, let's say, 10 bubbles per second. This is what you can achieve with a small stack. With a very big stack, you will have 1,000 bubbles or even more in this time. So this is, according to my understanding, not to function any longer.
So where do you see the responsibility to set up the standards? Because somehow, of course, you can maybe say it's a political thing, but on the other hand, it's also the industry that has an interest in establishing certain standards. So who should be the driver?
Well, the regulation committees do exist, and the market will be a driver. Yeah? And also, I have experienced a lot of need for leak detection and advice on leak detection in the discussions that I had at the exhibition so far. So I think that also the community needs to push. Yeah.
Is it also something that you see the requirement or leak testing requirements are growing because of the industrialization of the technology?
Absolutely, yes. So we have to deal with regulations which are often focused on safety, on approval testing. So we are talking about temperature cycling, pressure cycling, measurement, stabilization of permeation over a duration of 30 hours, total test time 500 hours. Okay, this is suitable for approval testing. This is not suitable for industrial serial testing. So we need to find ways, we need to rethink in a way how do we convert the existing test recipes, the existing test methods how do we integrate them into industry in order to be fast, to match up with the cycle time requirements in an industrial serial production. We are talking about fabs with 10 million or more bipolar plates per year. So if I calculate 24/7, then this means 10 million plates means one every 30 seconds. 24 hours a day. Yeah? So we need to find fast methods. Yeah? And this is one of the challenges, to convert the existing regulations, as I said, often for approval testing, to the world of industrial serial testing.
I open again because we're almost at the end. Are there any questions from the audience? Okay. Seems not, so I'm gonna have the last questions. You already mentioned the fair this week. What is your wish for the future to make sure that the requirements are set in place, I guess, as fast as possible? How do you think that it should be approached to make it possible?
Yeah, I can only ask for contributions from the community. Yeah, come to your leak detection expert, discuss with us, hopefully. Yeah. And then we can distill the requirements. We can be the channel who communicates to directives, who communicates to regulation committees, in order to have common ground in the future.
Yeah, I mean, at least I already saw that the topic came up several times also here on stage. So there are organizations or companies that have the interest and the need for common ground, for standards. We've talked before that there's also another company setting up a platform to make sure that they can support in regulations and standards and testing. Because here we just talked about leak testing requirements, but of course there's so much more that needs to be standardized and tested as well. So thank you very much for being here with us, Dr. Rudi Konwitschny.
Thank you, Muriel.